Hello everyone. We're going to start another little series on our 4-inch precision low profile sine plates. We have a 7-part series going on the ins and outs of that already, and so I don't want to reproduce a whole lot of that again. But what we'll do is we'll try to get a couple videos showing you some of the clips and the processes that we may have been changing, or that we're might do some things a little different, or some things we haven't shown. So anyhow, I have enough stock right now where we're going to be doing 21 of those. We've already had 5 or 6 of them that we've sold. We'll be selling them for $450 each. Rachel will be showing you some pictures from some of our old footage of the sine bar, because I actually don't have any right now. My goal originally was to make one of those for myself, and so far they've been in such demand I don't even have one of my own yet. And out of this 21, I don't think I'm going to get one. And so we'll get these ones finished up and just get them to the people that are on the waiting list. And what we're going to do then is we'll start another batch, and then I'll probably do another batch of probably 30 or so, because at that time this will be a good project for the kids because of repeat work and just train them on stuff a little bit more involved than the boring bars. But a lot of people have been saying they've been having a little trouble contacting us. We do have our email on the about page of our website, and what we're going to probably do is we're going to probably start putting that email address. We'll just show it in the video over here so you can see it there as well, and Ray will just put a little spot in there at the beginning. We'll probably do that on all of our videos from here on out, just to make it easier for those who are having trouble. And so anyways, hopefully with the email address, that will be, it's temporary until we have our own website, and we'll have a different email address. But that email will always be good even when we have the website, but we're just using it kind of temporary for the business now, because I just happen, with that account, I can make pretty much as many email accounts as I need or as I want. So anyhow, before we start, we just want to give a special thanks to the 3 monkeys. Many of you have probably heard of them. You got Pierre, you got Phil, and you got Robert, and they're in Canada. And we met them at Mr. Pete's and some other places. And anyways, they make some of these Machinist jacks, and they get this real nice wood box. And they got these Machinist jacks, and maybe a lot of you people have seen them. But these things are pretty good. And I've been playing with these. We got them in a few days ago. I've been playing with these and looking at the finish on there, and just a craftsmanship. And I tell you what, that's second to none. Very well done. These things will come in handy. A lot of times what you can use them for, if you've got long parts in the vise on the mill sticking out, and if you're milling, you don't want to bow it down or whatever, you can stick these jacks on the end, and it gives added support. And you can use that that way. We'll put a link to Stan's one of his videos, or actually an Instagram page, I think it was, on one of his videos where he's using these jacks. He's got a casting, and he had a clever little setup where he's using them in the vise, holding this casting with the uneven edge. And because these things are adjustable, you know, they work really good. So if you got uneven, oddball parts like Stan had over there, he was using these jacks over there to hold parts. And so you just leave it to your imagination. But this part will come off. You have spacers that you can use on here. You get spacers that if you need taller. Like I say, a very well thought out design in here. A nice little kit. And so, and I believe this is, if you want to lock it in place, I think is what that is. Maybe Pierre can correct me if I'm wrong. So that if you want something that's unmovable, I think that will go in there. They also have a nice little bar that you can go in there and adjust those with. And so it's a nice set, and that'll come in handy. And I like the fact that we have this wood box like that with a plastic insert, because a wood box like that, it makes it much harder for rust and corrosion to hit on your parts there. So anyways, this is a nice set of Machinist jacks, and we just want to thank you three guys so much for that. The workmanship again is outstanding. It's a beautiful kit, and I do believe they sell those, so we'll put links to their website, and so that you can visit their websites and they can explain even more details about these. Another thing that we want to demonstrate is, because at this point I don't have one of my own low profile sine plates, I'm going to have to use just a regular sine bar here. I had a number of people contacting me with email wanting to know how you set a sine bar up, and for me this was something that you know, I started this job way back many decades ago, before CNC was, well, if it was out there you never heard of it, definitely in the primitive days of it. And so for me it was something that I kind of cut my teeth on, because of I worked in a gauge shop at that time, and we used these sine bars, sine plates, compound angle plates. We used them quite often. And in fact, this to give you an idea how far this goes back, this was made December 1, I think is when I heat treated it, December 1 of 1982. So this unit, this little bar, is quite old, and I've used that bar a lot. The nice thing with the low profile sine plates, I made that so that these can stick, and you can use them in the vise, and it's lower. I think it's about 5/8 or 650. I can't remember off the top of my head. So it's more shallow, because even when you stick something like in your vise over here and you stick it up, you're limited with the room, with the jaws that you have, because this is so tall. By being low profile, it gives you more bite with the jaws, and makes it a lot nicer. And actually what we want to do is we're going to put a link, because that reminds me too of with Stan at Bar Z. He just did a video where he was using his, and it was a good video. I really liked it, because I know it was a product that we make and that I built, and we gave him this one. It was kind of a unique situation, but he ended up getting the one that we brought Bar Z. Razor Ray won it, and Stan wanted it, and so they worked something out. I was going to build one for Stan anyhow, and Stan wanted that one because it was unique and it was engraved and it's one of a kind. And so Razor Ray, with his big heart, he let Stan have that, and then I took the one I was going to build for Stan and I gave to Razor Ray. But anyhow, we'll put a link to Stan's video where he's actually showing how to use that. But anyhow, I'm going to show you right now real quick how to use these, because there's been a few people that have been asking me that. And here lately, one of the guys, he was wanting to know if we would build a 5-inch, and I told him no, we'll probably won't build a 5-inch, we'll be building a 4-inch. And anyhow, he's a real nice guy. He retired pilot, and he's hobbying around a little bit here. And so he has a Machinist handbook, and in the Machinist handbook, his tables are set. If he's going to use a sine bar or sine plate, the tables are set for 5-inch or 10-inch. And so one of the things, I'll show a couple of things that you can do. One of the things you can do is you can take a calculator like this, and by the way, this calculator is an awesome calculator. If you need a Machinist calculator, this calculator right here, let's see if I can, a Machinist Cal Pro, I think they got the Machinist Cal Pro 2 now. I don't know if you can get this exact one. I think they got a more advanced one, but it's from Calculated Industries. You can find them on the website. I just saw on the latest MSC flyer, they got them in there. I think they were about $80 roughly. But any scientific calculator that's got a sine function will work. And I automatically know, just because I use it all the time, that if I'm going to want a 30-degree angle, I know for every inch. Now this sine bar is 4 inches as well. When I say it's a 4-inch sine bar, it means the center line of this roll to the center line of this roll, that is 4 inches. And these rolls are made out of D2. And I just want to show you how brittle the D2 is, because this is one of the things I've talked about too, and I just seen. You can see I got a nice chunk over here that's missing on this roll. It's not missing on the tangent point there. Everything's set good. It didn't destroy it. But when I put the screw in there, and I only got a couple threads in there, that D2 is so brittle, when I tighten it down, it just popped. And it took some of the, a big chunk of that material all the way around there. So I had to use a longer screw. It didn't ruin it, but it could have. So you got to be careful, especially with steel like D2. It's very brittle if you make things out of it. And so you definitely got to get a thread engagement that goes in quite deep to keep from doing that, or counterbore the holes, as some of the viewers suggested on there a certain way, and that will help give you strength. So anyways, I know that this is 4 inches from center to center. A 5-inch bar would be 5 inches from center to center. You've seen, if you watch some of our videos, I got that big 10-inch sine plate, and that will be 10 inches from center to center. And that's the thing that you need to know. I actually have a smaller one that's 3 inches center to center. And it's important that you need to know that, because that's how you can figure out your angle. And it's just by using math, you can figure out what gauge block stack that I need in order to get whatever angle you want. In this case, I know that if you're going to do a 30-degree angle, I know it's for a half-inch stack with a 1-inch center to center would give you 30 degrees. Well, if I got a 4-inch sine bar, it's easy for the 30 degrees. I mean, I just timed that by 4, and I ended up with a 2-inch stack. If I want to go with a 5-inch sine bar, I just timed it by 5, 10-inch sine bar, times it by 10. But if you get a scientific calculator like this, and it's got a sine function, which is I use this conversion button and sine, it's pretty simple. All you do is you type in 30, and that'll be your degrees. You hit this convert, you hit sine, and you can see it comes up with 0.5. Now that's for a 1 inch. If I got a 4-inch sine bar, I just hit times 4, and that would equal a 2-inch gauge block, is what I'd have to stick under here now in order to have you know, just about a perfect 30-degree angle. I mean, I say just about perfect because it depends on how good and accurate the sine bar is. So if I had a 5-inch sine bar, I would have times that by 5. I would have come out with 2.5. If I had used my 10-inch one, I would be timing it by 10. And then you would have ended up with a 5-inch stack. And so anyhow, that's the way that you use that. Now, if you don't have the calculator, you do have the Machinist handbook. And as the gentleman that contacted me, he said that it just had set up for a 5-inch and a 10-inch. Well, if you're going to go for a 30-degree angle, that table will show you that you need a 2.5-inch gauge stack, and that's in a 5-inch. So if you have just a regular calculator, you just type in your 2.5, you divide it by the 5-inch, and that will equal the 0.5, and then you just times it by the 4-inch, and then you come up with the 2-inch. So even though the tables in the Machinist handbook are set for 5 and 10, well, if you're in the 5-inch, you divide it by 5, times it by whatever your center to center is. If you're in a 10, divide it by 10 and times it by whatever the center to center is, and you can still come up with the right answer. And then you can, which I'm not going to demonstrate, you can I guess use some long formulas for that, but here's 2 simple ways of doing it. Like I say, getting a good calculator like this would be one of the nicer, easier ways. But this calculator, I just want to show you how nice it is, because when you're doing the math, for doing right triangles and stuff, you got an adjacent, you got the opposite, you got the hypotenuse and an angle. So if I go 30 degrees on my angle, I just need two things on there. And if I have my hypotenuse 4 inches and hit my hypotenuse, well, and then if I want to see what the opposite is, I got 2 inches. Want to see what the adjacent is of the angle? Now I got the 3.464. So this works really great for doing a right triangle formulas. All you need to know is a side and an angle, or 2 sides or 2 angles. You can figure out everything else you need with just this, and by continually pushing the buttons on the angle, it'll go around and tell you the angles on the other two or the other sides as well. Another nice feature on this, if you want to figure out your RPMs for your drill, let's just say I'm just going to throw out a figure of we're using high-speed steel without coolant in 01. I would probably run at about 35 surface foot. So I type in 35, and that would be my cut speed. So I got that set. And I'm going to use a 1/4 inch end mill, or a 1/4 inch high-speed drill. So then what I would do is 0.25, and then I just push diameter. And now I need to know what RPM to run that. So I just push the RPM button. Okay, 535 RPMs, and that should give me a pretty good speed. Once you get one drill tweaked in where you know the surface foot, whatever size drill you use, you just stay with that surface foot. It's real easy to calculate your speeds and that you need over there. You can do the same thing if you got a end mill, and you can set your feed rate and stuff based off how many teeth you have on there. You can calculate all of that so fast it's not funny with this. Another feature that you'll have with this, which I won't demonstrate, but you can do bolt hole patterns with this. This has drill charts, tap charts. It's got 3-wire gauge charts, and I haven't used any of this stuff, but it's in there. They got a nice instruction book. So especially if you're just starting out and you don't have a calculator yet and you plan on getting one, definitely look into this one. I don't get any money from them, but this is the best machinist calculator that I've ever had. When I brought it to my full-time work and I showed it off to a few guys, it didn't take them but just a few minutes before they ended up ordering their own. So anyhow, that's just a couple of things that we're going to go through. And one other thing that we want to do, it'll be on the cubes that, or the squaring blocks that we're making. We had James Shaw, he was asking, because we've done the series, and he was asking, what is the formula for figuring out the shims that you need to grind in this block in order to tilt the angle right. So we're gonna cut away just for a minute, and I'm gonna get my squareness checker, and I'm just gonna get it set up the way you would use it, and kind of show you the formula that I'd use to know how much of a shim I'd have to grind to get that so that it will go at the proper angle. Okay, this is a squareness checker. If you watch some of the videos that that we made, that you've seen me checking how square this is coming out. One of the things I do, I got a pivot point that's way down here at the bottom. Got my indicator at the top. I try to get as much area as I can. Now these blocks are nominal size, plus or minus 10 thousandths, are 5 inch by 5 inch. I'm just going for nominal because all these blocks I just want flat, square, parallel, and square. I'm not concerned about the dimensions. So we got 5 by 5 nominal, and we got 2 1/4 nominal. So what will happen is if I take this and hold it up, if I measure over there, I got about roughly, just eyeballing, about 4 3/4 of an inch. So you need to know that, and I'm not going to get real precise here because when I'm grinding these shims I don't need to, but can you see that dial, Cat?
A little bit.
Okay, I'm going to set that for 0 because this one is in the process. We got a flat and parallel here and real close in the other directions, but I just got to bring it in. And obviously we made videos on that, so I'm not going to be making another video on it. But anyhow, I set my dial at 0 here. And if I want to see how square it is, if this thing is square, it'll be 0 on this side too. But if you can see the dial, I'm about 3/10,000ths of an inch off. Now that's total indicator reading. It's 3/10 off. It's high here, so it means that this block is leaning like this. So what I need to do, I actually need this side to be shifted lower so that the block can kick back this way. If I have a total indicator reading of 3/10, what I need is I need to do my math figuring on 1/10 and a half, because it's basically at 1/10,000th and a half out of square, because that would be half of your total indicator. So if I could grind that squareness out using that number there, I can get to square. But now if I would just take 1/10 and a half, well, I'm going to probably shift quite a bit the other way, because what I do, I have this distance from here to here is like I say, about 4 3/4. My distance from here is 2 1/4. So I really need to have that shift in this length. It's going to be a lot less than that length. And so if I take 4.75 and let's see, we can divide that by 2.25, it looks like it's almost, I got 2.11. That's about how much of the ratio that I have. In other words, this side right here, the measuring contact, is 2.11 times what I have here. Now, when I grind this with the shims, I got to be careful, because again, these are approximate. Because if I leave about 100,000ths of a step here and about 100,000ths of a step here, I'm really down to maybe just about 2 inches. So it'll be a little off on that. What I would do at this point, though, I just know that I'm roughly got 2 times the length, roughly. 2 times the length that I'm measuring here than here. If I need 1/10 and a half that I need to grind to get that back square, I know I need about half that much in the shim, because I'm 2 times the length here, I'm about half the length here. So if I have 1/10 and a half I need to take here, I need to grind my shim at about 7/10 difference, about between 7 and 8/10, and that should put me really close. And what will happen is you grind that shim and then you come back and measure it, you're going to find out that shim distance is less and less, where you might clean up all the way across, and you might come out and just even get it small enough where you're just taking a blank pass on the one side and not the other side, just to get that minute difference in order to get that to shift. And with a little practice, it actually goes pretty fast. But anyhow, that's the math that you use. It's the contact point that you're using from here to here. Your measuring surface over here is how I got to shift it. If I need 1/10 and a half in this distance, about half the distance here. So that's how I determine what I have to grind that shim. We had another person that commented, and I didn't get a chance to respond in the video in the comment section. He was seeing when we're using this squareness gauge over here. Let's see if I can get this so that you can see the dial a little bit. He was asking about the angle that I have set up over here with this indicator tip. And anyhow, it looks like it's a steep angle, and he's wondering if it was affecting the reading. And again, this block is just kind of close. It's within 1/10 or 2 all over, because it's roughed in. I got to finish it up. But what we want to have over here, our measuring surface is here, our indicator tip is at an angle here. I could care less where this indicator's at. I need to know the angle of the needle over here, the tip of the indicator, in relation to the surface that I'm measuring. So this is the surface I'm measuring, this is the angle. And you want that, if you can, to be 10 degrees or less, and that should give you your most accurate reading on this 1-for-1 on your dial. If you get this set so that now you can see I just pulled this needle out, and now my needle's like this, and I'm going to come in And I gotta be gentle here and touch. And then I'm going to take a reading. I'm not going to have a 1-for-1 on my dial. What it's going to actually do is going to make it hypersensitive. Instead of, if it's 1/10 out, it might show that it's 3 or 4/10 out. The more that I go at the angle, you get your cosine error in there, and you're not going to get the 1-for-1 reading, but you still got the 50 millionth resolution in the needle. And what it does, it just makes it, if you're over 10 degrees, it makes it actually more sensitive. So in one sense, it's going to give you, you know, if you're going to compare it to something else, it will be more accurate. Like if you're comparing a gauge block stack with what you're grinding, and your angle is beyond the 10 degrees, and you're showing 0 on your gauge stock block, and then you show 0 on the part that you're measuring, it will be even more accurate than as if you had that at the 10 degrees. So anyways, this is why I'm moving in this direction. This is why I'll put the needle down like that. We try to get the indicator in a direction that you guys can see. And I try to get the needle position just right. And so then I can read real nice over here, just moving the lever. And again, here's my measuring surface. There's the angle that I want to have. Try to stay 10 degrees or less. Sometimes it's hard to get it positioned, because if you go 10 degrees, you might be hitting at the pivot point on your indicator, and it makes it harder. So, but don't freak out if you say, hey, I can't get under 10 degrees, and let's say you're at 25 degrees. You're just going to have, if you're comparing it to a known size, you're going to have a more accurate reading is what you're going to end up. It's going to be more sensitive. The problem is, if you read and it says that I need to take 3/10 off because I'm going to a gauge block stack size, and your needle is, say, at 25-30 degrees, and it says you might have 3/10,000ths to take off, you take the 3/10,000ths off, and then you go to measure your part. What you're going to find out is you're probably undersized. That's what you got to watch for, because you won't get a 1-for-1 reading. So one other thing, just another little pointer. When you're doing that real high precision work, and you're working something in, regardless where that needle is going, don't even trust if it says I need 5/10 to take off. Based off a gauge. If I have a 2-inch gauge block stack set up over here, and I want to grind something at 2 inches, and it shows on the needle I need 5/10,000ths more, don't take the full 5/10. Take half of it. Measure it again. I'll say, wait, that's kind of weird. That took 3/10, not 2.5. Well, see, if you kind of cut that number in half, so now if you're down over here where you need only 2/10, just take a 10th off, remeasure it. So if you're really working into something that's really fussy, where you're measuring the accuracy to a known size, like a gauge block, as you get down there, just keep cutting that number in half. But once your indicator reads 0 to your gauge block in your part, you'll be good. And so anyhow, there's just a couple little tips on the indicator and using them, and how to set the tip in relation to the surface that you're measuring. We're starting one of our other projects that was on the back burner for a little bit, and finally got to it. Had a lot of time off work from the holidays, and took some vacation, just trying to catch up on some things here. And anyways, what we have is we're making the low profile sine plates. We're going to be making 21 of them, and this is the piece that we're making right now. And the stock I bought was I think it was a DCF 3/4 by 3/4. I need 5/8 by 5/8 on the one piece, and the other piece a little bit smaller. But so I had to do a lot of cutting down. But we're going to be making this piece right here, and I got these blocks squared up now, and we'll be cutting. I got lines scribed on this one, but I just want to show you some of the setup work that we do when you do multiple pieces, especially the more you do, your setups can really help out on getting really good time on things. And so, I mean, that can be as simple as using your stops on your quill, using stops in your vise. I mean, just simple setups, or some of the setups that we got that we'll go over is on the cutoff saw. Anyways, on these blocks, because they were about 820 by 820, and I had to cut these ones. I cut 630, and then I just clean up cut there. But the other 21, these are 630 by 630. So there's almost 200,000 stock on all of them that came off, from one side. And for half of them, there's 200,000 stock that came off that side. And like I say, these ones here were just cleaned up on the one side because we're going to bandsaw a lot of that stock off, and that way we can repurpose this nice chunk of DC53. I posted an Instagram when I was squaring these up at 2 at a time. I love these Miltech cutters. They work fantastic. This is a homemade cutter. Maybe sometime in the future we'll do a video on making these. You can buy the cutters as well as the inserts from Miltech. The inserts are a little bit pricey, but they're one of the best cutting inserts out there, and I just want to give you an idea how awesome this cutter is. I've rotated these inserts for some other purpose already, but what I'll do is I'll start cutting with new inserts, and I'll start cutting until the parts start getting warm. Then I know I'm getting some rub. With this style cutter, most of the heat goes out in the chip. A lot of times your part is barely warm at all when you cut, even taking some nice cuts. But what I'll do is when I can start seeing if the finish is suffering on the part, or if it starts getting warm, I can just take this to the bench grinder, and then I just hit the corners a little bit, and then I come back and cut again. So the amount of stock that I've taken off the part was quite a bit. There's 42 pieces here. I ended up using just 2 tips to cut all that stock. I mean, the floor is full of chips. And so there was a lot of chips come off. I just used 2 tips. That's how awesome this was. I just keep going over to the grinder and grinding a little bit. So even though the inserts are a little bit pricey, I think I'm just taking a guess right now. The last time I got them, I think they're around $15, $16 an insert. You got 4 cutting edges. I just used 2 tips to cut all that stock off this DC53, and that material is pretty close to D2, to give you an idea. Now I was taking 75 thousandths off on a rough pass, 5 thousandths cleaning up, flipping them over, doing approximately the same until I had them in the size. So anyhow, that's how awesome these cutters are. What we're going to do now, the first setup though, is just taking, and I just got to get a good surface over here. So I got an end mill that's well used on this point, but higher up on the flute it's not. So that works out real nice because the end mill is almost brand new right at this point where I'm cutting on the side flutes. But all I have to do is get a nice clean square cut. And this works pretty good because my vise is tuned in real good. I get a real nice square cut. Once that is done, I now have an edge that is nice and square with a real nice finish on it. I'll take a file and file it off, and I'll set that one aside for now because I already have this one done. We got the side mill on that, and then I just scribed some lines where I want to cut. And so we're going to move over to the saw right now, and we're going to show you the setup that we have for that. So what you have on this saw, I made a new back plate to go on here, and I took the old back plate and actually put it on the front. You'll see that a little bit later. That way I got some nice long jaws. I got this slotted so I can move that jaw in and out. But I made this piece right here with these slotted holes, and then I can take a 1/4 20 set screw and I can hold this plate on. Then on the back rail, what I did, I added 1/4 20 taps, 1/2 inch from the bottom and 1 inch spread, and then a 1-inch spread this way all the way across. And so I made these slots so they're about 1 1/16 inch, and so I can have a screw. I got infinite adjustment with this block, and what this block does, it works really nice because what I want to do is I want to set this part in there, and then I already got it preset. I can set it in like that, and then I can cut. I can make that cut, and I got this stop right back here. I got it set so that it will stop before it cuts the thing all the way off. And what's nice about this, I can be machining the one end on these, doing other machine work, while the bandsaw setting up cutting unattended. And if you can have a saw like that or some other tool going all by itself with very little input on your part, and then again it speeds up the process. And like I say, this jaw I can move in and out. What I've done, I just taken one of the other pieces over here because this back jaw can pivot. It's the same thickness over here, so when I put pressure on it, it'll hit here and it hit here, and this plate is thinner. So I just hold it up against that, and I'm going to move this jaw back just a little bit because here's where the blade's going to be at that point. And then I test it to make sure it's tight, and then that's just a matter of we'll shift the camera in a minute so you can see the stop. The saw is already on the stop. It can't go any deeper than this. So we have a stop set up here. We have a stop set up there on the desk. Go ahead and shift the camera a little bit, Ted, so that you see the stop of the saw over here. So we're stopping in 2 places. I've actually cut 2 pieces. This was the first one, and I knew my saw blade was getting a little dull. It doesn't help when you're cutting off a reamer shank that you think is soft and it turns out to be hard. So I knew that blade was a little bit soft. One of the reamers I had, it was soft, and the second one I did, it was hard. So anyways, I wanted to get as much life as I could, and I got a reasonably straight cut on that one. But on the second piece that we just cut in the video, you can see that the set on the saw is coming out and it's wanting to cut a little crooked. So for these, I'll be changing the saw blade and we'll get a better cut on there. But anyhow, we'll be cutting off over here. We'll be getting this nice chunk of metal, and then we'll make things like this. This has been repurposed from other products, and what's nice, I can put clearance holes for a 1/4-20 in this side. I got 1/4-20 tapped holes in that side. So you can use this, you can use them as parallels with stops. You can use them in so many different areas, but one of the areas I like to use them a lot is I can bolt these up to our cubes over here, our squaring cubes. And then I can bolt that in, get that indicated in, and if I got multiple parts that I need stops, I can put a screw in there for a stop. I got this as a stop. It works really great for grinding, machining, or if you're doing inspection work on parts, multiple purposes for that. And some of them we make a little thinner without the tap toes, and those just work real nice as stops in here. We got some that are longer, some that are shorter, and you've seen a lot of the stuff we do on videos. I make a lot of this kind of stuff because it really works well in setups. And most of this stuff that I make with these little blocks is over leftover pieces. that I have on some of the projects we're doing, like here on these Sine plates. We're making 21 more of these right now. We do have a video series on this, making them. We'll probably be doing a few more videos on them because we're going to be doing setup work, and we're going to start doing these more in a production run, and they'll become an item that we'll be adding for selling. I didn't know how much interest there would be in these, but then when I started making them, I had a lot of people contacting, wanting to know if we would make them and if we would sell them, and there was enough interest in it, so we started making them. I've already made 5 or 6 of these, and originally I was going to make one for myself. The demand for them has been high enough so far. I still don't have my own, and I'm not even sure if I'm going to get my own out of this set of 21. We're probably going to have to make another run after that. Anyways, if you're interested, just leave us some feedback in the comment, and we'll put you on a list. Thanks for watching.